Hello, good evening, and welcome to today's class. As usual, we are here to look at a few JAMB past questions. Today, we are looking at those that are related to kinetic theory of matter. And though I have made some videos in the past that are chemistry based, I have also made those in physics and in biology. So look at these key questions here that are related to kinetic theory of matter. Would you be able to answer questions like this? So I'm going to treat a good number of questions that are related to kinetic theory of matter that are real jam past questions. This will help you evaluate yourself and learn more even as we proceed. Look at the first question. The first question is talking about gas laws. It says the volume of a given mass of gas in V centimeter cube, P millimeter mercury, and you observe that real numbers are not given to you. How do you approach this? Look at the second one, which is graph, and they ask you from the diagram above, which can represent an ideal gas. Do you know the difference between an ideal gas and a real gas? These two are not the same. So in this video, I'm going to make explanations in such a way that you'll be able to answer this question perfectly, and several others that are related to kinetic theory of matter that might look confusing. So I would just try as much as possible to make everything clear to you. So we are going to answer these questions now, and then we proceed. Sorry, let me put my phone on flight mode so that we wouldn't have much disturbance. Thank you. All right, so we continue. Okay, I think the light is even more better now. So let's look at, okay. All right, so these are answers to the previous question, though I'm going to make the explanation clearer to you. All right, so the first question is asking us that we are given a certain amount of gas, a certain volume of gas at a certain pressure. Now, the pressure was reduced to half. So, observe that no numbers are given. So, they want to test your ability to think. That's just simple. They want to test your understanding of these laws. Now, in one of the videos I've earlier made, I've explained these things clearly, but let me still explain them so that you'll be able to answer them very well. Look at the two images here. Now, in the first one, there is pressure. Let's say the pressure there is 2. Let me use those arrows. We have 2 green arrows. That's pressure. That's the force exerted on the gas. So we have 2. Now look at the second image. We have 4. Now what do you observe? Where you have 2, the volume is high. It occupies more space than where you have 4. Where you have 4, the volume is smaller. So remember a law that says if pressure is high, the volume reduces. I will not say the law. We are going to look at them in detail. But I just want you to use your discretion, to use your understanding to answer this question. So now, but in our own case, they said the pressure was reduced to half. So if you reduce the pressure, what happens to the volume? The volume increases. So it's as though initially we have the second image, and now we reduce the pressure by double. We reduce it to half. So what do you think will happen to volume? The volume will be double. So if we increase pressure by double, the volume will reduce to half. If we reduce pressure by volume, if we decrease pressure by half, the volume will increase. The volume will be double. I don't know if this is clear. Anyway, I have another picture where I will explain this very clear, but you have to get this concept. The more the pressure, the smaller this volume, because the thing will compress together in a single space, in a simple small space. But if the pressure is very low, that is the force bringing the gas together is low, it's not much, the volume will be high. I hope this is clear. All right, we have what we call an ideal, and so you can now see the answer is 2V, so the volume will be double. All right, so but look at this, the answer to the next question, which is question 2. I'm talking about questions I showed in the previous slide. Now, we have what we call ideal gases and we have what we call real gases. This is English, please understand. When we say ideal, we talk about based on assumption. This is what should be. But when we are talking about real gas, we are now talking about what is actually obtainable in reality. But when we say an ideal gas, we're talking about what it should be. Do you get what I'm trying to say? Okay, let me give an example. If I say an ideal student, it means a student that is not lacking in every area. He observes reading time very well. He has time management skill. He has this, he has that. That's an ideal student. But if I now come to you as a student, that's the real student. I might now meet some of these things are lacking, some are not. That's the real thing. But an ideal student is expected to have this. So we have gases like that too. Though we might not have an ideal gas, but there is an assumption that there is an ideal gas and it behaves in this manner. So if you look at the graph there, you see carbon dioxide, you see methane, you see hydrogen, you see helium, and then you see ideal gas. Please note this graph and observe how it is. Now, I saw two good questions repeated, and you are going to see them. I gave one of it as an assignment, and one of it I've solved it. Two questions with similar graph in 2 different years. I don't know why JAMB would ask this. It's too simple, because why would they ask the same question last year and repeat the same without changing anything this year? Is that not too simple for you guys? All right, but what I'm trying to say is that ideal gas, they are assumed to be gases that are not affected by volume. The volume is assumed to be very, very negligible. We have a formula to represent it. Please, I will use another slide later to explain this better. But just know that if you see a graph like this, observe the line. The line is a straight line graph, a straight line that you are seeing there, on which the word ideal gas is written. So what does it mean for it to be straight? It means that the conditions are not affecting it. If the conditions were affecting it, it would have behaved, it would have deviated from as a result of changes. Look at other gases, the 4 others. Look at their behavior. Do you get it? So you observe their behavior. But this one, it just moves straight. There is no change. All right, so let's continue. So there are some key things you need to know, and they are very fundamental. Please master this. JAMB can ask question in any way from this point. What are these things? That matter is made up of tiny particles that are in constant motion. Now you may say, this is very simple. Let me explain something here that you need to note. Now we know everything is made up of particles, right? Yes. But then, do you know that these particles are in constant random motion? What does that mean? It means that the particle that made up of the table on which my this thing is standing is made up of particles, and these particles are in motion constantly. You may ask, something that is solid, how could the particles be in motion? You see, and that's why I'm telling you now. These particles are in constant random motion. The motion may vary. It may be a vibration around a fixed point, which is obtainable in solids. I hope you are getting this clearly. So the motion may vary, but all of them, they are in constant random motion. I hope this is well taken. Please don't forget this, because based on this knowledge, you'll be able to answer many questions if you know this. Now, The kinetic energy of molecules determines the state of matter. Very, very important. You see, that's why I made this thing simplified. I made it simplified, and I just want you to be patient. Listen to me carefully. Whatever you are doing that can be decided, just drop it and understand this thing once and for all. Once and for all. Just settle down and get this. It's worth it for you to sit down and know, instead of you didn't get it very well, you just want to move fast, and it cannot be that beneficial. Okay, now we said these particles are in constant random motion. Now we are saying again that the kinetic energy of the molecules determine the state of matter. You and I knows the state of matter: solid, liquid, and gas. Now, why are some substances solid? Why are some substances gases? And why are some substances liquid? So, the kinetic energy of molecules will determine its state. For example, solid molecules, they are closely packed together and they vibrate about a fixed point. Do you see the constant random motion we're talking about now? Are you trying to tell me that the solid particles are not in constant random motion? Well, to a layman, they are not, because we are seeing the stable standing, right? Yes, but in reality, these particles are also in constant motion. But the type of motion they undergo is what is called a vibration about a fixed point. Now, we said the state of a matter is determined by the kinetic energy of molecules. What is kinetic energy? Kinetic energy is the energy that an object possesses by virtue of its what? Yes? Yes. Emotion, the motion aspect. Potential is by virtue of its rest. Yes. So this is the energy that puts molecules in motion. The energy that molecules absorb to keep them running. This is the kinetic energy. An object gets this energy by virtue of its motion. Alright, so I've already explained that of solids, they are closely packed together and vibrate about the fixed point. The liquids, the molecules are closely packed, though not as close as in solids, and they can slide over each other like in water, liquid water. Okay, then in gases, the molecules are widely spread or spaced out and they move freely and rapidly. This is clear, I believe. Let's go. Good. Here is a good example. Now, observe solid, liquid, and gases. Look at the space in between the molecules. In solids, closely packed. If you see something like this in JAMB, please listen, take your time and read carefully and understand. Okay, now the red line is for energy. So as the kinetic energy is increasing, the movement of the particles, the distance between the particles become more higher and they will be able to move freely. So the motion increases, and that's the green line. While if the kinetic energy reduces, then the force of attraction begin to be in effect. So they will be closely related together. They will be closely packed together. I hope this concept is well understood, because you may be asked questions in different ways. Okay, by the way, we are going to see some questions, really JAMB questions. Okay, let's continue. Okay, this is another example. We have water. When water is ice block, look at how it packed. That's in the first image there. That's how the water is packed when it is in solid form, ice block. But when it is in liquid, you can see that the molecules are a little bit separated. They can slide over another and move. You'll be able to pour it. Yes. But what if it is in gaseous form or steam? The molecules are far separated and they can move randomly in air. I hope this concept is very clear. Okay, let's continue. Then we have Brownian motion. Brownian motion has to do with... Why am I explaining these things, by the way? I observed that relying on past questions alone cannot solve the problem when it comes to JAMB. Yeah, there are different ways it works. The videos I've made in the past for my students are basically questions, but I realize that it doesn't work. There are some questions that JAMB may ask that may not actually be exactly questions directly repeated. So that's why I'm taking time to explain this, so that I just want it to be that any question that they mistakenly ask under this, you can answer it perfectly. That's why I'm taking my time to explain this. And beyond JAMB, you know that I hope you know that your 100 level, you have to do chemistry as a science student, whether you are biology, whether you are studying pharmacy, you are studying medicine, you are studying nursing, I hope you know that you must do chemistry. Okay. So, Brownian motion has to do with the random movement of particles suspended in fluid due to collision with the moving molecules of the fluid. I believe that this is clear, but I have a picture also to explain this. Maybe it will be better. All right, so look at this image. Look at the first one there with yellow particles just moving randomly and hitting one another, moving around. Look at the second one also. So the fluid there, the fluid could be air, yes, or the fluid could be water, and maybe when you put other particles, so those particles will be moving randomly and colliding with the water and the wall of the container, moving all around. So this is what Brownian motion is talking about. In the second picture, we have the fluid molecules to be in the blue color, and the suspended particles, that's the particles that are moving due to Brownian motion, are the one in red, which we have one there. So that's the concept, and that's what he's trying to explain. And okay, phase changes. Let's quickly, I'll explain some key things here that are important. Now, from solid to liquid, molecules gain energy and break free from each other. Very important. If you want to melt candle, what happen? What normally happen? So the molecules gain heat energy. They absorb heat energy. So that heat energy give them more ability to move around. So they separate, they break free. In vaporization, that's liquid to gases, molecules at the surface escape due to energy gained. When you are boiling water and it starts boiling, what happens? Steam rises up. So the molecules at the top, they escape because they have gained enough kinetic energy to make them fly. So they begin to escape in form of vapor. Then we have boiling, rapid vaporization throughout the liquid at a specific temperature. That's their boiling point. So boiling point has to do with rapid vaporization due to liquid at a specific temperature. Each substance has its own boiling point separate. You know this. Then freezing, liquid to solid, molecules lose energy. Now I want you to get this. Look at freezing and boiling. In boiling, molecules absorb energy enough to start vaporizing. But in freezing, the energy that the molecules have is now removed, so that the molecules' kinetic energy is reduced. And that's why if you close a fridge completely without putting anything, just close it, what happens? If it works overnight, by the time you come in the morning, you will see liquid droplets. So what actually happened? It is because the water in the air, because the energy is removed gradually, and this is what fridge does. As the refrigerant, the liquid is circulating around the fridge, it is removing energy. It is removing heat energy now. It is removing heat energy. So as the water in the air is losing energy, it changes to vapor, to liquid, so that it will not be able to move again. All right, so I believe that you know all these phase changes. Though I have an image, I don't want to waste much time here. You know what we call sublimation. For a substance to change from solid directly to gas without passing through the liquid state, that's what we call sublimation. You should know this. Example are iodine. We have camphor, and we have several other substances that behaves in this manner. Now, if you want to change them from their gaseous state back to solid, it is called resublimation. I won't waste my time explaining freezing and melting. You know all this. You know condensation. but I want you to get this sublimation. All right, then good. Oh, this is a real JAMB question, 2012. This question says, during a titration experiment, 0.05 moles of carbon dioxide was liberated. What is the volume of gas liberated? Oh, this question is actually based on a law. In one of the videos I have made, please, all the videos are there. You can check my handle and watch them one after the other if you are stumbling on my videos for the first time. If you are my returning student, okay, I believe you can remember that I have treated this, and I've given you assignment questions on something similar to this. So if you are just joining us, you are just seeing this, I have some students that I'm coaching. We have a WhatsApp group. I do give them assignments. We do mental drills. We have online meetings. We learn in various and diverse ways. The goal is just to prepare the candidates adequately for JAMB, not just preparation anyhow, but overall preparation, physically, mentally, book-wise also. Yeah, so if you would like to join us, just drop interested in the comment section. I will see how I can bring you up on board. All right, so when I treated the kinetic theory of gas, of matter, there are some laws here we've stated. Definite proportion, I think I put it under stoichiochemistry. I don't know, but I know that I did a video on that. Now, Avogadro's law told us that 1 mole of every substance contains 6.23 times 10 raised to power 23 particles or molecules. Don't get it wrong, get me right. Now, 1 mole of every substance contains 6.23023, if I got it right, times 10 raised to power 23 particles or molecules. It can even be electrons. Yeah. So equally, it says 1 mole of every gas, 1 mole of every gas at standard temperature and pressure occupies 22.4 decimeter cube. That's the volume. So they are just trying to test your understanding of that law, whether you know it. And this question is simple. You can see the solution there. So if 1 mole occupies 22.4 decimeter cube, then 0.05 mole will occupy what amount? So it will just be 0.05 times 22.4. Do you observe that 22.4 will not be given to you? Nobody will tell you 1 mole of carbon dioxide will always contain this amount. So if you don't know it, you don't know it. And that's why I'm taking my time to explain. In case you come across questions like this, please, please, please. So the correct answer is D based on our calculation. We move because of time. Then we have gas laws. Please be able to state these laws. Boyle's law, Charles' law, very important. Now, I have tried to condense it as much as possible to make it easier for you to remember and to comprehend. At constant temperature, the volume of a gas is inversely proportional to pressure. If you can only remember inverse proportion between volume and pressure, I think you can be able to put the English together. By the way, it's objective questions. So Boyle's law talks about pressure and volume. And the type of relationship between pressure and volume is what? Inverse proportion. What is this saying? If pressure increases, volume reduces. That's inverse. This is going this way, this is going this way. So they move opposite. If volume increases, then definitely pressure decreases. So, but if pressure increases, definitely volume increases. That is to say, if you add pressure, the volume will become small. The gas will be compressed to occupy small space. If you reduce the volume, the pressure, the volume increases so that the gas occupies a large space. It's very simple. The formula is there, please. The formula is there. And the relationship is linear. The graph is linear. I will show the graphs also. I've seen, in fact, I've answered during my own year. I've answered a question like that where they just show graphs, only graphs. They say which of these represent Boyle's law or Charles' law. I remembered very well, and if you check, you will see it. All right, Boyle's law. Charles' law talks about pressure, talks about temperature and volume, provided that pressure is constant. Remember, in Boyle's law, temperature is constant, so we are dealing with pressure and volume, While in Charles' law, we are dealing with temperature and volume. Pressure is constant this time around. So, and the type of relationship that exists between them is direct proportionality. That is, the volume of gas is directly proportional to temperature. If you increase temperature, volume increases also. That's direct proportionality. Anything that happened to this one will happen to this one. So if you are reducing temperature, volume will be reducing. If you are increasing temperature, volume will be increasing. Do you get this? On the contrary, in the Boyle's law, as pressure decreases, volume increases. I hope my explanation is clear enough for you to understand. Please let me know. All right, so let's go. Yeah, observe these two graphs carefully. Now, they may decide to just show only one. They may not show the second one. They may use the first one. So both of them mean the same and they represent Charles' law wherever you see them. Remember, in Charles' law, we are talking about volume and temperature. And you can see temperature at the bottom, volume, yes. So, but what if you see pressure and volume? You should know that that is Boyle's law. Okay, let's go. Yeah, this is Boyle's law. Pressure and volume. I've stated this already. So any one of these that you see also, you should know what they are talking about. So they may just decide to just draw graphs randomly. So, but be careful, just watch carefully. Usually is the first that they do show most times, because it is more familiar. You'll be more familiar to it. So just observe it very well. Let's go. Okay, yeah. I have a few assignment questions for you. Now, if you are not my student and would like to do the assignment or would like to be part of us, I've already told you what to do. I said just write interested in the chat box. That's the comment section. I'll see how I'll bring you up so that you can join us. If you are my student and you are watching this, now this is your assignment. Question 1 and 2 are here. All right, so the first question here says, I'll just read very fast. I don't want to waste much time. I've already made it as easy as possible for you to answer. So, and these are JAMB questions, please, so take them seriously. You say a gas occupies a volume of 2.5 liters at the pressure of 1.2 atmospheric pressure. I told you what ATM means. If the pressure is increased to 2 atmospheric units, what will be the new volume of the gas, assuming the temperature remains constant? Now, the trick is this: always bring out the parameters given to you. You'll be able to know what you are dealing with. If you see only pressure and volume, or from the beginning they say temperature is constant, you already know the law that is talking about temperature is constant now. So you should know that you have to apply Boyle's law. If they are talking about temperature and volume, pressure is constant, you know that they are talking about Charles' law. So I've given you the formula to calculate there. Now, what are we calculating? We are calculating V2, correct? So make V2 the subject of formula, do your calculation and find out the correct answer and write it. You know how we normally submit it. Submit it to my DM on WhatsApp. Good. The second question is there, please. I've dropped the formula to use. I've even made V2 the subject of formula for you already there. So use this second formula. Thank you. Let's go. Okay, so if you are new, you can subscribe, you can like, share, and you can drop your comments. Are my explanations clear enough for you to understand? Is there any suggestion you have? Maybe, am I fast? Yeah. So please subscribe, like, so that it will go to many other students who are also preparing like you. My goal is to have as many as possible, to have 250 and above in JAMB. It pains me when I see serious students who are really willing, but they lack support. This is one of the reasons why I'm doing this. I hope you know that nobody is paying me for this. Alright, so please get it. I'm not asking you to pay anything. I'm doing it for free now for you to get it. So if it is not clear, let me know. But the only way you can assist me is to help me get this across to as many students as possible. That's the impact I'll be able to make to my society. So like, if you are my student, you have subscribed already, hit the like button. If you are getting something, if you are not getting anything, no problem. But if you are getting something, you are learning something, like, you can share to your other colleagues, and also drop your comment. Let me hear your feedback. All right, so we go to the next question. Is this assignment question? No, I will not give you this as assignment. This is too cheap already. I've brought out all the parameters. I've dropped the formula. Now there's what we call a general gas equation, general gas formula. This formula is the combination of Boyle's law and Charles' law, and the formula is P1V1 over T1 is equal to P2V2 over T2. Now in this question, we have that, okay, this question was 2014 JAMB. We have that 200 centimeter cube of a gas at 25 degrees Celsius exerts a pressure of 700 millimeter mercury. Calculate its pressure if the volume increases to 350 centimeter mercury at 75 degrees Celsius. Okay, now observe that all the time change your temperature to Kelvin. If they say 25 degrees, just say 25 plus 273. The answer will be in Kelvin. Just add 273. That's the Kelvin, this thing for 0 degrees. So just add 207. So I've already worked it out there. I've already brought out all the parameters. All that remains is to substitute them in the formula and calculate. I think my answer was C when I calculated it. So I'm using the formula P2, making P2 the subject of formula, and making P2 the subject of formula. So I have P1, V1, T2, all over V2, T1, and that's the formula you are to use to calculate all of this. Alright, so I hope this is clear. So let's move. I want to finish first. Okay, then we have Graham's law. Okay. Though I've not seen any question on this, but you can also master it. I've discussed it in the previous class on chemistry. Dalton's law of partial pressure, I've discussed this too. Then we have combined law. I've already stated it earlier. The combination of Boyle's law, Charles' law, Gay-Lussac's law put together. Then that's when we have P1V1 over T1 equal to P2V2 over T2. The best approach is always bring out what is given to you. You will be able to know what you are looking for and the right formula to apply. Thank you. Okay, we have another question here, though I didn't solve it to the end. Yeah, I've solved it to the end, but I just decided not to put the answer. So, to what temperature must a gas at 273 Kelvin be heated in order to double both its volume and pressure? So, do you see this kind of question? Very tricky. Yeah. Do you observe that only one parameter was categorically stated? Yeah, when I saw this question, I smiled. I just know that many students will not get this kind of question. They won't. I just know. And the reason is because nothing was given. So, only few will be smart enough to get the remaining. Actually, they were given, but not in a way that you can see them. So, if I said a temperature is given, and I'm now asking to what temperature will it be heated? I've already told you that T2 is not given. T1 is given, T2 is not given. Do you get that? Now, in order to double both its volume and pressure, to double, both its volume and pressure. It means P1 and T1, no, not T1 now, volume and pressure double. It means V1, V2, P1, P2 are given. How do you get them out? Just assume a number for V1 and V2. No, sorry, for V1 and P1. Then the number for P2 and V2 should be double the number you assumed. So since they say for it to double, so it means you have to have a number, then the two of it should be double the number you had for one. Simple. I hope this is clear. Don't miss this kind of questions. Okay, so I've already brought out everything. Actually, we have to calculate T2. I have applied the formula. Now look at these parameters. Which formula do you use? Boyle's law, Charles' law, or general gas equation? Of course, general gas equation, because you have P1, V1, you have T2, V2, you have V1, V2, you have T1, T2. Can you see? So just bringing out the parameters, you will be able to know what formula to apply. Okay, let's go. Now, always remember this. Standard temperature and pressure. 0 degree is always equal to, these are standard conditions and units that you should always remember. 0 degree is always 273 kelvins. And please always change your temperature to Kelvin. I think that's the only thing I can emphasize here. Very, very important. Very, very important. 1 atmospheric pressure is also equivalent to 760 millimeter mercury, if I remembered clearly. But I want you to know, always change your temperature to Kelvin. I've stated this law of molar volume. 1 mole of every gas at standard temperature and pressure contains or occupies 22.4 decimeter cube of volume. Good, we are here. What's the difference between a real gas and ideal gas? I started explaining this earlier, and I told you earlier that there is a slide where I have dedicated completely to discuss about this real and ideal gas. So what's the difference? Okay, here is the difference. There is an equation for an ideal gas. I told you an ideal gas is an assumed gas which does not actually exist, because all gases have factors that affect them. But an ideal gas, we are talking about a gas where the molecules occupy a negligible volume and the collision is assumed to be perfectly elastic. And there is no intermolecular forces. There is no assumption for intermolecular forces. And you cannot do this for gas, because if you compress gas, if you bring it together, there can be an intermolecular forces. In that previous video that I have made, where I discussed all those laws, I have talked about fractional distillation of liquid air. If you can remember, I told you that there are specific or specified instruments that you can use to fetch air in this atmosphere and continue to compress this air until it turns to liquid. By the way, have you not thought, why is it that this gas, this liquid cooking gas that we use, when you shake the cylinder, you feel it sloshing inside as though it's liquid, of course, which it is. But once you open it, it's starting to turn into gas. Have you ever asked yourself why it is so? Yeah. So air can be changed to gas, to liquid. So in fractional distillation of liquid air, they fetch atmospheric air using specialized instruments. They keep compressing it, lowering the temperature until the gas molecules begin to interact with each other and become liquid. So in ideal gas, they assume that there is no interactions, which is not possible at some conditions though. So, but you have to know all these things. Good. So this is what makes an ideal gas. Ideal gas follows the equation PV is equal to nRT. So that's the equation for an ideal gas. This equation is a little bit advanced. Please, you don't need it for now. I think so. But in case you see it, no problem. I just want you to know that this is what is followed. But you may be asked the difference between gas, ideal gas, and real gas? And I think I've seen a question like that. So what is real gas? Real gas is actually what we have in reality. And this real gas deviate from ideal behavior at high pressure and low temperatures. If the pressure is high and the temperature is low, the gas has force of attraction. The molecules are brought very closely together, so the force of attraction begins to act on the gas molecules so it can turn to liquid. So the attractive forces between molecules exist. So this is what makes it different. In ideal gas, it is assumed that there is no force of attraction between the molecules. Please, if you cannot know anything, know this difference. Thank you. Alright, so tips for calculations. I think I've already said this earlier. Write down the given values to identify the gas law or equation to use. Please, I urge you. Ensure all units are consistent. Make sure that temperature is in Kelvin. Please, pressure in chemistry, most times it is given in millimeter mercury. Just use it like that. Or it is given in atmospheric pressure. Just use it like that. But when we come to physics now, most times you have to change it to Pascal. So note this. Rearrange the formula and solve systematically. Now, sometimes you have to make one factor or one parameter the subject of formula or the other, or you have to rearrange the formula. So once you bring out the values given to you, you would be able to know the right equation to apply, and also if there is need for you to rearrange the equation before you solve it. So these are tips which can be helpful. Then molecular interpretation, we have energy and the particle motion. Now there is something very important I want to bring out here. So we have phase transition, boiling, freezing, energy transfer. All these processes is energy transfer. If you are boiling water, what are you doing? You are trying to transfer heat energy from the wood or gas that you are using to heat it into the water molecules. So for water to boil, you have to put energy into it, putting it into a pot and applying energy. What if you want to freeze? You are trying to remove energy. So it's all about energy transfer, either removing or adding. Okay, so that's what I want to bring here. Now, another key point you should know, during this phase, temperature remains constant because energy is used to break intermolecular bonds. All right, I should be rounding up. So we have another JAMB question from 2017 here that says a gas sample with an initial volume. Okay, volume was given, expanded to this. So V1 and V2 are given at constant pressure. Now listen, pressure is constant. So you should already know the kind of formula we are to use. So now we are asked, what is the ratio of the final absolute temperature? Are you getting it now? So temperature, this is Charles' law. So we are asked the final temperature, the ratio of the temperature. Okay, so how do we work this out? We already have all the parameters given, and we have our equation as V1 over V2 over T1 equal to V2 over T2. But we are looking at the ratio of the temperatures. So we have to rearrange the formula in such a way that we have T1 over T2 over T1. All you need to do is cross multiply. If you cross multiply, then you divide. So here we will have T2 over T1 is equal to V2 over V1. So by the time we substitute, because we are given V already completely, we want to know. So you have 9.75 over 3.25. If you divide, you would have 1 at the top. Then you have, you should have 3 at the top because it's 9 divided by 3.25. So it will be 3:1 because 9 divided by 9.75 divided by 3.25. If you cancel out, you have 3 at the top and you have 1 below. So you have 3:1. I hope this is also clear. Okay, so I have more tips for you. Forgetting to compare. Okay, these are common exam traps. Forgetting to change your degree curve. There is a reason why I'm emphasizing this, please, and I want you to take note of that. Confusing direct proportionality and inverse proportionality. Now, I have seen a question where they say, which of the following is the mathematical expression of Charles' law? They only use proportionality sign, so please note it. Direct proportional, V is directly proportional to T. You are seeing that sign there. Look at it. Confusing direct proportionality, e.g. Charles' law, with inverse proportionality. In case they ask for mathematical representation of Charles' law, Boyle's law, please be able to know that V is directly proportional to T is for Charles' law, while P is inversely proportional to V is for Boyle's law. I hope this is clear. So misinterpreting units like using volume in centimeter cube instead of converting it to dm cube. Okay, you don't have this problem, please, in chemistry. In chemistry, if you are given in centimeter cube, use it in centimeter cube. If you are given in decimeter cube, in meter cube, use it the way it is given. Except if maybe V1 is given in centimeter cube, but V2 is given in decimeter cube, you cannot use it that way. You have to change either to centimeter cube or to decimeter cube. All right, thank you. Here are the remaining questions for assignment to my students. You would join us if you are interested. You can join us. Very simple. Just drop in the comment section that you would want to be part of us, and I will get you right part of us. So here is the third assignment question. Please read it and answer it. Submit it on my DM. Remember, I've given 2 questions earlier, so this is question 3. Question 4 is here. I have question 5 here. I have question 6. Yeah. Okay, this is the question I was talking about earlier. I have question 7 and lastly question 8. Yeah. Thank you everyone for being with me for this period of time, and thank you for listening. If you have listened to this end, yeah, I know you are a serious student. Some people would have dropped since because it's boring, I'm not getting it, this and that, or flimsy excuses. One secret to excelling in academics is resilience, ability to stay. Even if it is not looking as if you are not understanding, but you stay. By that you would understand. But if it is becoming difficult, it is becoming uninterested, and you now say, I'm going. When will you sit down to learn it? No time. So I salute you if you have watched it to the end, and I would like to know those of you that have reached to the end. I know those that have not watched to this end will not know what I said at last. So if you have watched to the end, just write watched to the end. Let me know those of you that have done that. Thank you very much. God bless you. So we meet in the next class.